I don't know about you, but I quite like drinking water. And actually, I do know about you. All of us like drinking water. We kinda need it to live. Unfortunately though, for 2.2 billion people, the water that they have to drink isn't quite safe, as it is salty, polluted, or full of dangerous diseases. This leads to 3.5 million deaths per year. However, that's all that they have access to. This is why Teamwater, a fundraising campaign by Mark Rober and MrBeast, is trying to raise $40 million this August to provide clean water solutions to 2 million people, with every dollar donated providing a year's worth of clean water to one person in need. Donation link is in the description. But what's the purpose of this video then? Well, pumping water from the ground is one of the ways that Teamwater plans to provide people with access to lots of clean water. And as a geologist, I'm here, along with some help from a very awesome friend.
Hello there!
To explain how getting water from the ground actually works. So, let's hop straight into it. Welcome to our village in the middle of a savannah. Unfortunately, the weather here is dry and hot for most of the year, so collecting water from rain isn't really an option. And the local online water source, a small pond, is stagnant. So it's full of diseases like cholera and lots of algae. This means that there aren't really any clear, clean options for water that are currently available, or at least ones that we can see. This is an aquifer, a body of rock underground that holds water. Of course, IRL aquifers don't exactly look like this, but it's just a diagram that I made to show you the features of an aquifer. Firstly, there must be an area of rock that is porous and permeable. This means that a large volume of the rock is space that could hold water, and that water can flow between those spaces. Some rocks that fit this requirement are rocks like chalk, limestone, and of course, sandstone. The second important feature for an aquifer is for the rock below the water-bearing rock to be the opposite of the rock above. It needs to be impermeable so the water cannot escape. Some good examples of this are granite or clay. It's important to note though that some of the rock above the aquifer does need to be permeable, so the water can flow into the aquifer when it's rainy. This is known as aquifer recharge. Okay, so we found our water source. Only issue though is that it's way underground. Oh? Right. Let's hand it over to the awesome Eligriv to show you how we get water out of the ground and into homes. Hiya!
Thank you. I'm Eligriv, also known as Rod, and I'll take it from here. I'll explain to you how we managed to get this water out of the ground. So, you might know the device, a water pump, but you might not know how it actually works. So basically, just a lever and a piston. Let's take a closer look. On its up position, the piston creates a void inside the cylinder, which, like when you try to drink in an empty bottle, creates suction force and attracts water into the pipe. On the down position of the piston, the valve at the bottom closes and traps water inside. Repeat that action a few times, and you'll have more and more water inside the cylinder until it is ready to flow out. However, a pump isn't going to work constantly. The water source can be a victim of droughts, and the pump itself can break. So, to continue supplying water to the community, you need another element: storage. When an automatic pump isn't working at full power, the water gets stored in a tank. The most common example is a water tower. It fills up at night to help pumps supply all the water when the demand is high. In our case, however, a lot of water pumps are manual, so the water distributed is proportional to the water needs. But they have a weak point: contaminants. Bacteria and sediment, such as salt, can infiltrate the water source and contaminate it. So there is a final step between the source and your thirsty mouth.
While water from aquifers is often plentiful, fresh, and cleaner than other options, that doesn't mean that it's always 100% ready for consumption. Which is why further treatment processes will take place. water taken straight from the aquifer is pushed through activated carbon filters to remove organic matter and other small particles. Then, the water is sterilised to kill any bacteria or other harmful pathogens. This can be done by adding small amounts of chlorine, ozone, or by blasting the pathogens with UV light. Any small amounts of salt in the water can then be removed by pumping the water through a tiny membrane, leaving just pure water. This is called reverse osmosis. And after all of this, we can now enjoy some safe, clean water, which is something every person on Earth has a right to have access to. Thank you very much for watching to the end. We really hope that you learned something today.
If you want to do your part and help provide a year's supply of water to someone, then you know what to do.
Go to teamwater.org to donate.